Hello, today we're going to be talking about Module 17.5, which is solving quadratic equations graphically. So we can start off with this Explore activity really quick. It's got the graphs of the three quadratics. It is parabola A is the blue one, f of x equals x squared. Parabola B, h of x, is the green one, x squared plus 4. And then C is the purple one, x squared plus 8. So if you remember, that's just what's moving it up, is those four. So now on the same coordinate grid, graph the function g of x equals 4. So what that is, that's just going to be a horizontal line on 4. So describe the graph, it's a horizontal line. So if you look at parabola A, how many points does that intersect? We have 2. Parabola B is 1 and C is 0. So what we're going to be doing is just seeing where that intersects that g of x, which is equals 4. So use the graph to find the x-coordinate of each point of intersection in the graph g of x and parabola A, which is the blue one. So we're going to have, looks like -2 and 2. So you have -2 and 2. Now for D, use the graph to find the x-coordinate of each point of intersection on the graph g of x and parabola B. So it looks like you just have 4. And that's it. Oh, sorry, it's not 4, it's actually 0. So yeah, it's 0, 4, but the x value is 0, so it's going to be 0. And you can double check. You could do 0 squared plus 4 equals 4. So 0, so 4 equals 4, so it is true. All right, so we're going to show you two different methods on how to solve this. The first one's going to be graphically. So you can solve a quadratic equation that's in the form a times x minus h squared plus k equals c by using the expression on each side of the equation to define a function. So we're going to be breaking this up into two different parts. So basically, if you look at example 1, we have two different parts here. The first one is just the 3. So we're going to have g of x equals 3, which is the green line, the horizontal line. Now the next one, we have f of x equals 2 times x minus 4 squared plus 1. So it's going to go up 1, and that minus 4 goes to the right 4. So that's going to be our vertex right here. And then you can find a couple other points with our with a t-chart, or if you want to use Desmos to graph, I'm okay with that. So what you're going to do is just basically find where they intersect, and you're going to find your x value. So it looks like x equals 5, x equals 3. So right here is where they intersect. So the solutions to the equation are 3 and 5, your x values. So for number 2, I'm going to let you guys do that, but remember you're going to have two equations. That's going to be one of them there. The next one is going to be a horizontal line on 10. So if you have a horizontal line on 10, so it'll go straight across, and then the 3 is positive, so you'll have to find out where they both meet. All right, so the next one is solving quadratic equations graphically. So what you're going to have to do is first write the related function for the quadratic equation by rewriting the equation so that one side is 0, and then replace the 0 with y. So instead of doing what you did before, we're going to get everything on one side and solve it that way. So if you look at the original equation, so you have 2x squared minus 5 equals -3. What we're going to do is we're going to add 3 to both sides. So we're going to get a 2x squared minus 2 equals 0. So now we have to set, instead of a 0, we're going to put a y there. So for step 1, write the related function, add 3 to both sides to get that. The related function is now y equals 2x squared minus 2. Now we have to make our xy table. I prefer them like this, but that's just me. And then you're going to put in like -2, -1, 0, 1, and 2. And then you just have to plug those into that equation and find your points. So we have -2, 6, 1, 0, 0, negative 2, 1, 0, 264. So you're not going to really plot 264, but the other ones you can plot, and then when you graph it, you get it right there. And then the zeros of the function, since there's no horizontal line here, it's just going to be wherever it crosses the x. So it looks at negative 1 and 1. Now, you can also, if you really want to, you can just plug this into Desmos and use the calculator. It's a tool for you to use, so you could use that. For this one, the real world problem, you are going to have to go to Desmos to actually solve this. So many real world problems, particularly those involving motion of falling objects near Earth's surface, can be modeled by quadratic functions. So what we're going to have to do is find the get a graphic calculator or Desmos. So we'll go to Desmos and we have the equation. Okay. So you have the equation for step 1. It says negative 16t squared plus 20 equals 5. So you can have negative 16 t squared plus 20 equals 5. Which you're actually going to have to break that up into, you can do a y equals negative 16 t squared plus 20. So that's one equation. And the next one, you're just going to have, you could do a g of x, or you could just do a y again. It'll be a different color. So you can just do y equals 5. And then if you notice, it just puts that horizontal line right there. And then you can see where it crosses. So it looks like it crosses at 1. So you can see where the blue line crosses the red line. So it crosses at 1. So we can do the same thing for your turn on number 5, where it says a squirrel in a tree 46 feet above the ground and throws a chestnut that lands a bush 36 feet below. So what we're going to have is our y equals negative 16t squared plus 46. That's one of your equations. And the next one is going to be equals 10, because it's still 10 feet up. So you can just do a y equals 10. And you might have to zoom out a little bit. And you can see where it actually crosses that green line. And it looks like it crosses, if you want to, you can just press that. It crosses at 1.5, so it's going to be 1.5 seconds. So graphing calculators or Desmos are nice to use for these. So for here, it would be 1.5 seconds. So your original equation that you're going to have is going to be, you could put y equals negative 16 t squared plus 46 equals 10. Now it equals 10 because it fell from 46 feet up to 36 feet below, so it's still at a positive 10. That's where that 10 comes from. And then the next part is the same thing. I would use Desmos for this. So it says a dolphin jumps out of the water, quadratic function, y equals negative 16x squared plus 20x, shows the dolphin's height in feet above the water after x seconds. How long is the dolphin out of the water? So we're going to put this into the Desmos. So y equals negative 16x squared plus 20x. X squared plus 20. That's y equals negative 16 x squared plus 20x. So that is the calculator, and then you can see, hey look, it's out of the water for 1.25 seconds. So it goes up, it's at 0 and then 1.25 seconds. Same thing if you look at number 7. It says a baseball coach uses a pitching machine to simulate pop flies during practice. Quadratic function, y equals negative 16x squared plus 80x plus 5, models the height in feet of the baseball after x seconds. The ball is caught at a height of 5 feet. How long is that in the air? So that 5 feet is the 5 that's right here. So what we're going to do is you're going to go to Desmos. And we're going to put in y equals negative 16x squared plus 80x plus 5. And now you can see, if you need, you don't really need to zoom out or in, but it is a parabola. And if you just touch there, it is how long is the baseball in the air? It goes up and down, and that is 5.062 seconds. So definitely use Desmos on a lot of these, and it can help you out. If you have any questions, please reach out to me and send me an email, and I'll get back to you as soon as I can. Thanks. Have a great night.